into Cytoscape. Okay, so let's give that a shot. This is Cytoscape. Okay, it's another IDE. It's a very nice product. It's set up for the most part like YED. There are some differences, and it has some things that give it some additional power. So this is basically what we'll be exploring today. Let me go pull in this file. Now notice we're going to import the file. Okay, this isn't necessarily native to Cytoscape. So we go to import, we say network multiple file types. It asks us to choose a file. We'll choose test.gml, which is what we just exported or saved. And then we'll say import. And if everything's gone well, it will pull in our structure. And if you look here, it looks like it did a pretty good job. Let's talk a little bit about the layout of the Cytoscape IDE. Okay, we have a control panel here which lets us view some basic statistics about our network. Okay, we have a network called test. VisMapper is actually something that lets us control the way that our network looks. Okay, and we'll talk about that a bit more too. The editor lets us modify our network, and then filters, of course, let us query the network. Okay. This window down here actually will let us slide over the network and bring parts of the network into the visible area. This is important because some of the networks we'll be looking at will be very large, and we will want the ability to sort of focus on just, say, one part of it. Okay, so let's bring this into the center so that we can do things with it. And one of the nice things about Cytoscape, which sets it apart from some of the other IDEs that we'll look at, is that like YED, you can just add to it. So if we want to pull in some extra nodes, we can. We can adjust the way this looks however we want. Okay, pull this around, just select and pull. And we can add edges, okay, which you pretty much just click on it, drag it toward a source, and pull it toward a target. Now, this is sort of important. Most of the interactions that you'll deal with in Cytoscape are actually directed edges. Okay, so if you want to capture bidirectional information, you'll have to actually do something like this. And it will, now you're reflecting that this direction flows in that these links flow in both directions. Okay, and you can do you can go some way, you can actually describe it if you want, but you can go some way toward pulling them around as well. If you want, you can sort of move things as needed. Okay, and so it's just important to understand that for the most part we'll be dealing with directed links, okay, directed networks here. So let's keep adding a few more edges. Okay, I'm actually going to remove this edge. We don't need that now, if it lets me. Yeah, we'll delete selected edge. Okay, let's add just a few more of these guys. Like this. Okay, and we've got our sort of nice little network here. One thing to keep in mind about visualization, we haven't really talked about this too much. One of the principles that we'll learn in trying to visualize graphs is we want to minimize crossings. Okay, if we have to have crossings, we want them to be mostly like this. But the truth is, crossings are really easy to confuse with nodes. So one thing that we'll want to learn is how can we avoid crossings. Okay, and this is a very natural way to put together four nodes with links, but there's actually another way that's pretty straightforward. If we take this node, pull him down here, okay, you can see that we have no crossings now. Okay, this is a pretty simple example, but you can see that this would be a little bit easier to read. One advantage over this is that you can actually identify triads fairly easily. Okay, so this is one way to render the structure that will be very productive and can eliminate crossings. So this is one of the visual principles that you want to start to think about. We'll learn others as time goes on. But one of the great things about Cytoscape is that it's very easy to manipulate the network, to add nodes, to add links, to remove them as needed, and that's actually quite handy. One of the other great things about Cytoscape is it allows you to associate information with each of these nodes. Okay, so I want to direct your attention down to the data panel. Okay, the data panel will actually record data for nodes, edges, and the network as a whole. Okay, so we'll focus on nodes today, but it's important for you to understand that Cytoscape will also let you store data in edges as well. Basically, Cytoscape functions as a graph database, and the way that works is a little something like this. If we want to associate some data with, say, node ID 2, okay, we can do something like this. We'll create a new attribute, okay, and we'll make it a string attribute. Let's make it an integer attribute. No, I changed my mind again. Let's make it a string attribute. Okay, let's call it gender. Let's say that we're modeling people here. All right, we'll call it gender. And we'll give it a value. All right, say M for male. Okay, and then we'll come here and we'll say F for female. We'll assign some values here and make sure that that's filled in. Okay, so now if we cycle through each of the nodes, we'll see that we've assigned gender to each of these people. Okay, and it doesn't stop there. We can add other types of attributes. Okay, so let's now create an integer attribute. Okay, and this time what we're going to do is we're actually going to pull in the in degree. Okay, and when we talk about degree, we know that we have a total degree, an in degree, and an out degree when we're dealing with directed networks. So the question is, if we can put in the in degree, right, and we want to store an integer here, it's easy enough for us to go to the function builder, come in, we're actually going to select in degree as a function. Okay, and there are many examples of things that you can put here. We have to select, this bit's important, we have to select a unique identifier so that it knows what to calculate the in degree on. I suggest when you've dealt with imports and exported data, I suggest that you use the canonical name. It's not a perfect choice and there can be problems with it, but this is just something that you have to keep in mind. You have to have some way to uniquely identify the nodes. The canonical name is a good choice. Okay, so let's give that a shot. We want to apply this calculation to the entire attribute, which means it'll be calculated for all of the nodes. Okay, not just this cell. And we'll say okay. And in theory, if everything's gone okay, we should see the in degree being filled in with an appropriate integer. Okay, so if we look at ID 0, ID 0 has an in degree of 0 because all of its arcs are pointing out. Okay, so it is the source of 3 links. It is the target of none of them. Here we would expect 2, and that's what we see. Here we would expect 1, and that's what we see. And here we would expect 3, and that's what we see. Okay, so we've basically just built some simple data into our model here, and we can actually use that to, advance our cause, right? Do types of analysis that we want, and so on and so forth. Okay, so let's actually see how this can play into some of the visualization tasks that we might want to complete. Okay, so if we come to VisMapper, right, and we pick node color. Okay, node color is something that we may want to change. Okay, so let's talk about how we can do this, right? Let's say that I want to set the node color based on one of the values. Okay, and what I'll do is I'm going to select in degree. Okay, and we may have to fiddle with this a bit. So one of the things that we'll want to do is set this node color. Okay, now one of the tricks is finding, there's so many attributes here, so many things that you can change. Okay, so you pick out the node color, right? We'll double click. Okay, and then all of a sudden it'll ask you to select a value. What we're doing is we're picking the value that we want to use to set the color of the node, okay, which means that depending on what the value of the in degree is, we will show a different color. Okay, now there are a few different types of mappers. For something that's numeric like this, I like to use a continuous mapper. And what the continuous mapper will do is basically set the color based on the value. Okay, so you select node color, you select in degree, you select continuous mapping, and then it's going to give you this graphical view. Okay, and basically what you'll see is as the number goes from 0 to 3, so as it goes from the min to the max, it will shift from black to white. Okay, and that's exactly what we see here. If we take a look at 0, okay, and it still colors this yellow because it's the selected one, right? You'll notice this is black, okay? We would expect this to have an in degree of 0, and it does. Okay, we have this white here, and that's an in degree of 3. Okay, so what you're seeing is a continuous mapping of the color of the node based on the value of the in degree. Okay, so that's one of the visualization things that you can do that's actually rather handy. Okay, let's try another one. Let's pick a discrete mapper based on the gender. Okay, so there isn't sort of a range of values, it's one or the other. So we'll use a discrete mapper this time. So let's go find our node shape. Okay, so we'll find node shape. We double click to create. Okay, we want the node shape to be based on gender, and the mapping that we want is discrete. Okay, so what this will do is this will give us an option. What should the shape be for female? Okay, and so for female, let's pick a diamond, and for the shape for male, we'll pick hexagon just for fun. Okay, and as you can see, if the mapping has worked properly, the diamonds will all be female and the hexagons will all be male. Okay, and they are. So you can use these visualization capabilities to help refine even your analysis of these things. Okay, so these are just a few of the features that you